Hello, welcome. This is question 1 for Edexcel's C4 January 2009 paper. Okay, well, this question is all about implicit differentiation. It's nothing difficult at all. As I said, it's not even the harder ones. Because what you could do with this question, and they have done in the past, is put terms together where you've got 3xy to differentiate, which you have to obviously use not only implicit differentiation, which obviously just means differentiating y and putting dy dx next to it, essentially it's a shorthand, but you might also have to use your knowledge of the product rule. Okay, but because the individual products here, they're not two products together, we just differentiate them and use implicit differentiation where it is required. Okay, so what we're told is y squared take 3y is equal to x cubed plus 8. Okay, so the first thing we're asked to do is differentiate dy dx in terms of x and y. Okay, so differentiate like you normally would. This would become 2y, and obviously because it's a y, you put dy dx next to it. As I said, there's a reason for that on my C4 tutorial playlist for implicit differentiation, but it really, in the short word, it comes from the chain rule. Okay, as I said, obviously that should already be familiar, and that's take 3, you put dy dx next to that. Okay, and then we've got x cubed here, let's just differentiate it as you would any other formula of x, so 3x squared, and obviously the 8 disappears, because obviously it's 8x is 0, and you times by 0 goes away. Okay, what we've got is something times dy and something else times dy, so you can take dy dx as a common factor. Okay, so dy dx, and you take it as brackets 2y take 3 is equal to 3x squared. Okay, and now because that's 2y times dy dx, okay, as I said, we took it as a common factor, so we divide both sides by 2y take 3, so obviously we get dy dx is equal to 3x squared over 2y take 3. And that is your answer for part A. It's all we've been asked to do is find dy dx in terms of x and y, and it's exactly what we have done. So for part A, that's where you stop. Okay. Right, but obviously there's a bit more to this. Okay. So now what we have to do is find the gradient of c at the point where y is equal to 3. Okay. So that's obviously our gradient function. We've got y, but obviously we need x as well. Okay, so we've got y, we need to find x. Well, this is the only equation that contains y and x. Okay, granted, it's not just y is equal to 3x plus 8 or whatever easy as that, but we've still got enough there to be able to work out x. Okay, so if we put y to 3 into our original equation, we can substitute round and simplify to find x. Very simple indeed. So okay, so it'd be 3 squared. 3 squared take 3 times 3, which is the same thing, is equal to x cubed plus 8. Now quite clearly 3 squared take 3 times 3 is the same thing, so we say therefore what we're left with is x cubed is equal to 8, minus 8, sorry, because x cubed plus 8 is equal to 0. So that's just rearranging. And then what you would do is cube root both sides, okay? So if you cube root both sides, what you get is, well, what you might say is, well, we're cube rooting it, okay? Sorry. Yeah, when we square root up, we put plus and minus. But because we've got a minus 8 here, okay, there's no way that if we cube root that, we can cube number that will, there's no way you cube a positive number that will give us minus 8, okay, quite clearly. Basic math, okay, so therefore, if we cube root both sides, x must be equal to minus 2, okay. So if x is equal to minus 2, y is equal to 3, now we can use this gradient function that we worked out before to work out the gradient. Okay, so just input your numbers of y to be 3 and x to be minus 2 into that equation. Okay, so we get dy dx is equal to 3 times x squared. Okay, 3 times minus 2 squared, which is 3 times 4, over 2 times y, 2 times 3 take 3. Okay, which is obviously 12 over 4, sorry, am I going out 12 over 4? 12 over 3, sorry, which gives us 4. And that is the gradient for part B. Okay, so when y is 3, we get a gradient of 4. So it's very, very simple indeed. And a quick summation of this, okay? So we just differentiated each term, took out dy dx as a common factor, rearranged it and got our dy dx formula. Okay, that's part A. And part B, we were told y is 3, we need to find the gradient. Well, obviously, we've got the gradient function there, but we need to find x as well. So in case, just put y into the original formula, substituting down to find x, and obviously x was minus 2. Then we could put x to be minus 2 and y to be 3 into the gradient function, okay? And when we did that, we got a gradient of 4, okay? Just 4 units, we don't need to specify anything else. Okay, so it's a very easy first question to this paper, okay? Question 2 kind of steps it up a little bit of a notch for question 2, but as I said, nothing too difficult. Okay, so as I said, that was the end of question 1. Thanks for watching, and we'll see you in the next video.